October 3rd, 2025. Over the thin skies of Mars, a streak of light cut through the stars. 60 kilometers per second. Silent, electric, gone in a heartbeat. For a moment, Mars became the only world watching an interstellar visitor up close. But what exactly did we see? 3I Atlas, the third confirmed interstellar object after Oumuamua and Borisov, swept through the inner solar system this October. At closest approach, it passed roughly 30 million kilometers from Mars, 75 times the Earth-Moon distance. For a few precious hours, every eye on Mars turned outward. NASA's Mars Reconnaissance Orbiter with HiRISE, ESA's Trace Gas Orbiter with CASS, and Mars Express with HRSC. Each was reprogrammed to chase a target faster than anything they'd ever tracked. Before the agencies released a single frame, an amateur astronomer saw something they hadn't. Astrophotographer Stephen Burns downloaded Perseverance's night sky sequence, a run of long-exposure images meant to study stars. When he stacked them, a razor-thin line cut across the Martian constellations. Measured against the star background, it matched 3I Atlas's predicted velocity almost exactly. Burns published every step of his method: plate scale, timestamps, alignment checks. Thousands reran his stack. Some found the same streak, others found only noise. Then came the green flash. At 00:03 UTC, a single frame from the community stacks showed a brief emerald pulse above Mars. To some, it looked like ionized gas, the signature of dicarbon, the same molecule that makes comets glow jade near the sun. But when spectra from Mars Express and TGO arrived, they told a different story. A coma dominated by carbon dioxide and carbonyl sulfide, with very little C2 at all. Green light without C2 is like music without strings. Maybe it was excited oxygen, maybe an artifact. Without time-locked spectra, nobody knows. For now, the green flash sits in scientific limbo, a mirage to some, a sign to others. Tracking a target moving 60 kilometers per second from Mars orbit is like photographing a bullet from across a continent. HiRISE's world-class camera normally spots boulders on the surface. Here it had to aim at a dim speck tens of millions of kilometers away. Each exposure was a guess based on the latest JPL ephemeris. Too early, and Atlas was out of frame. Too late, and the opportunity was gone. Every spacecraft slewed off its normal orientation to follow the path. Telemetry and bandwidth limits meant no real-time tracking, only blind shots into the void. So when data didn't instantly hit the public archive, it wasn't silence, it was caution. Calibration pipelines for stationary terrain don't work on moving targets. Teams must rewrite them frame by frame to avoid mistaking cosmic rays for companions. The first analyses to trickle out revealed a puzzle. 3I Atlas's spectra look nothing like a typical comet. Where water usually dominates, carbon dioxide reigns. 10 times stronger, with hardly a trace of H2O. That alone suggests an origin in the cold outer regions of another star system, where CO2 ice is common and sunlight rare. Then came the metals. Nickel lines brighter than iron, as if the comet had been forged in fire then frozen again. Nickel should hide beneath dust and ice, yet here it glows openly. Perhaps impact heating or stellar radiation burned away the mantle, revealing its metallic heart. Adding to the oddity is its plume. A jet aimed not away from the sun, but toward it. An anti-tail, razor narrow and sunward. That geometry demands a massive nucleus resistant to solar pressure, possibly 10 billion tons or more. Heavy enough to stay on track despite outgassing jets. Every anomaly, like chemistry, metals, geometry, fits within physics yet pushes it to its limits. To separate signal from story, scientists climb the evidence ladder. Repeatability, multi-band confirmation, geometric consistency, and finally structure or maneuver. The higher a claim climbs, the harder it is for nature to fake. Right now, the streak rests on rung 1, reproducible but unconfirmed. The spectra stand on rung 2, multiple instruments, early data. Rungs 3 and 4 remain empty. 3I Atlas is now lost behind the sun. When it reemerges in early December, telescopes will look for 4 things: brightness, trajectory, jet structure, and spectral change. If the object survives perihelion without fragmenting, it could become the brightest interstellar comet ever recorded. The mystery is still unfolding, a slow dialogue between data and wonder. When the next images arrive, we'll see whether 3i Atlas rewrites our understanding of comets or just our imagination. Until then, question every frame, test every claim, and stay curious.